By now, all the presents have been unwrapped and put away, and everyone is settling into January, the least favorite month for many. When looking up statistics for people's favorite months, I could also find polls that stated January was a favorite, so it just depends on who you ask. There are actually lots of cosmic-related news to celebrate and look forward to in January 2025. Back in late December, scientists at CERN released the news that evidence of a bizarre antimatter particle was seen. Definitely an exciting gift for under most scientists' Christmas trees. So what is this bizarre antimatter particle? Here's a screenshot of a newly submitted paper from the ALICE, which is a Large Ion Collider Experiment website. It has yet to be peer-reviewed. I gave up muddling through it, but it does announce evidence of antihyperhelium-4. As names go, it sounds more like something found in your favorite science fiction series rather than a lab. So what is antihyperhelium-4? Let's start at the end of the word and work back. Helium is the second lightest and second most abundant element in the universe, with a nucleus containing 2 protons and 2 neutrons surrounded by 2 electrons. An extra fun fact concerning helium is, usually but not always, helium is atomic weight 4, but helium-3 exists, 2 protons, 1 neutron, and the moon is thought to be relatively rich in it, which could be a source of fusion fuel for future moon missions. So far as we know, electrons are fundamental particles, meaning they aren't composed of other smaller particles. Protons and neutrons are not, each being made up of 3 quarks. Protons have 2 up quarks and 1 down quark, and neutrons are made of 1 up and 2 downs. Somehow I'm thinking of football right now. However, 4 other types of quarks exist. One of them is called the strange quark. I think they are all a little strange. Strange quarks are different from down quarks because they have 25 times the mass of a down quark. And they also have, in quotations here, strangeness. Strangeness is a resistance to decay against electromagnetism and strong force. So, what do you get when you put a strange quark with 2 other quarks? You end up with a hyperon. Of course. These hyperons are unstable, but they can live long enough to join protons and neutrons. Hyperhelium-4 would be made by 2 protons, 1 neutron, and 1 hyperon known as a lambda, which is made up of 1 up quark, 1 down quark, and 1 strange quark. If all of this was not complicated enough, what researchers actually found evidence of in the experiment is not hyperhelium-4, but rather the decay products of its antimatter counterpart, antihyperhelium-4, which is made up of 2 antiprotons, an antineutron, and an anti-lambda hyperon. This is the first evidence of the heaviest antimatter hypernucleus yet at the Large Hadron Collider. So it was a big wow for all involved, even if most of the world is still puzzling out all the ups and downs of Quark World. Not to be confused with Chevy Chase's Clark World. So what else is there in January worth toasting? In the month of December, 4 more countries signed the Artemis Accords, the documents outlining principles for cooperation in the civil exploration and use of the Moon, Mars, comets, and asteroids for peaceful purposes. This brought the total of countries to 52. Canada was one of the 10 original countries to sign the newly created documents in 2020. Noticeably still missing are Russia, China, Iran, and Iraq, but let's not dwell on that. Perhaps 2025 will bring some surprise signatures. Also this month, social media is breathlessly announcing a rare lineup of planets, missing the point. As Earth's sky stated, planets in our solar system, when they are visible, are always in a line because they follow the path of the sun, the ecliptic, across our sky. On January 25th, here is what you will likely see if clear skies prevail. Note that Uranus and Neptune will only be able to be viewed with optical aid. Still a wonderful sight, but not quite what social media is promising. A fun project you can still be part of and will get you through the January blahs is tracking Mars retrograde motion. Mars entered retrograde, or backward movement relative to its usual direction, on December 7, 2024, and will continue throughout January into February 23, 2025. You can track the planet's progress by sketching or photographing Mars' position relative to nearby stars on as many clear nights as possible. So even if your January ducks don't seem to be in a row, there's always something to look up for.